Okay. All right. So let's make another game here. So I'm just going to do a new project. Um, Give it a second here. We're going to do the 3D Core URP, and I'm going to call this one, Twin Stick Mania, I guess. Sounds fine. I'm just going to go to my folder here, and I'm just going to make sure I'm in projects. Select that folder, so it's saved in there, and then I want to hit create project, and it's going to work on creating that project. And then we wait for it to resolve the packages. They must be resolved. It's exciting. So much anticipation. All right, so we'll start off with this business in here. So what I'm going to do is, I always just go into like a prototype process first, and then kind of go from there. So I'm actually going to grab these things and stick these all in settings. And then sample scene has sample scene, but I like to make my one scene just usually called level 01, just because the name sample scene doesn't work for me. So I'm just going to do Control Shift S and in the scenes and just call this level 01. Okay. Yay. All right. Then what we're going to do is go ahead and we'll create an empty, and I'm just going to call it game manager. And we'll just, oh, it's already zeroed out. That's fine. I guess because I haven't moved the camera yet. Down in here, I'm just going to go ahead and go to create, and we're going to create a new volume profile. And we'll just call this post effects because that's mostly what it's going to do. And then on here, what's it called? It's just called the volume. Yeah. Actually, can I just drag? No, do it this way. We're going to add a new volume. And then I'm just going to go ahead and drag this profile into the volume. And then I can add the overrides and things that I need. We'll play around with this a little bit, but obviously this is a little more flexible, but that's going to handle that. And then I'm just going to go ahead and get rid of this global volume. It's the same. I really could have just named that, I guess. That probably would have been smarter. Anyway, but that way you see how you would make one. I'm going to go ahead and just do a new folder, and I'm just going to call it effects. And I'm just going to slap this in here just so that, it's not out and about. We don't want things just floating around. First thing I'm going to need is to have a game board, right? So what I'm going to do, what I was going to do is I was going to start off the same way. I'm just going to have a prototype. I'm just going to have a flat thing, and then I'll make it work. And then after that, I'll start to add some pizzazz and stuff. So literally, this is going to be what we already did before, but I'm just going to make it, again, I guess. So let's save this real quick. And so we'll just do 3D object. We can go ahead and do a plane, and we'll make it bigger. R. There it goes. Okay. Let's say we do 10 by 10. Actually, I'm just gonna undo that. Lock this, and we'll do 10. Okay. So that should give us plenty of workspace. And then, and we're gonna call this. That's why it wasn't working, because it was renaming this. We'll call this the floor. So that's fine. Then let's go ahead, and I'm going to create just some walls here. So cube, let's call it wall. And I'm going to zero all this out. 0, 0, 0, except this needs to be 0.5 because it's 1 unit tall. So yeah, it's that size. That's fine. And the scale needs to be, let's do this a couple times. All right, needs to be roughly, so 100. Great. And then we're going to need to move this over. Probably 50 would be my guess on X. So let's try 50. And that would rotate right here. 50. Great. And then I'm going to just see anything else. I think that's all I need to do. I'm just going to go ahead and duplicate that. And we'll put in -50 for the other side, just so we don't fall off the world. And then we'll duplicate it again. I'm going to zero this out. And then we will do 50 here. And then we'll do 1 here, and I will do 100 here. So it's just scaling it in the opposite direction. I'm going to duplicate that and type in -50 on Z. And now we have our walls. Just to make this a little bit better so I can see what's going on, I'm going to create a new folder. We're going to call it materials. And inside of this, right click, create. We'll do a material and we'll call this floor material. And I'm just going to give it a color. Doesn't really matter. Just going to do more of a coolish gray color and just slap that on there. Oops, we'll do it this way. Floor. And then we'll do create material again. And we'll call this wall material. Probably get rid of this anyway, but start with this. Click on that and we will do, let's do more of a brown grayish color. And I'll slap that onto the wall, onto the wall, onto the wall, and onto the wall. And I missed a wall. Let's do it this way. That's not really where, it's this one. Okay. All right. So we've got that going on. I don't like the shininess of this, so I'm going to take the smoothness down so it's not shiny. The wall's going to stay shiny. I really don't care. What I'm going to do is put these in a group just so they're a little bit easier to deal with. So we'll just create empty and we'll just call this environment. I think that's right. Grab all these guys. I'm going to slap them in here so that they're easy to deal with. And I'm going to undo that because I didn't zero this out. 0, 0. Oops. Come on. Because if I zeroed it out afterwards, everything would shift over. I don't want to do that. So I got to undo that. There you go. Now everything should be good to go. All right. And let's go ahead and just make the player. So just I'm going to do this a little bit differently because it'll be easier to actually bring in the other elements. So I'm going to create empty. We're going to call it player. And we'll zero it all out, 0, 0, 0. And then I'm going to create a 3D object. And this time I'm going to do, let's say, a capsule. And I'm just going to call it player model. And I'm going to drag it onto player. And when I zero it out, it's going to go to the center where the player is. As you can see, I'm going to hit F to frame. All right. And the player needs to be up by 0.5 like everything else, so it moves it up. And then I'm gonna take the player model and I'm actually just going to rotate this. Let me see, W. So forward should be that direction. Just want to double check my camera. Okay, so forward should be that direction. So I can tell which way forward because the Z is pointing that way, the blue. Okay, so that means I need to rotate it this way. So I'm going to start rotating it that way and be like, oh, it's this one. And then I'm just going to type a 90 so that way I know. That way it looks like it gives it more directionality. Last time, if you remember, we did a cube and it was kind of hard to tell. And so I had the little gun nublet on there. What I want to do this time is I'm actually going to make different models that will go on the gun. So that's a little bit better. And let's go ahead and make a new material, create material, and we'll call this player material. And I'm just going to go on here again, and we'll make the player, let's make them pink. Pink is cool. Okay, and let's drag that onto the player model. That looks good. Pretty excited about that. And then I need a gun to start with. So we're just going to go ahead and create empty. And we'll call it gun. And I'm just going to take gun. And we're going to actually drag that also onto player. 0, 0, 0. But it will need to be forward because right now it's centered on this. So I'll hit W and I'm just going to pull it forward. So that way it's in front of my guy. So it's about 1 unit is right to where this is. I'm actually going to do 1.5 just to make sure it's not, that's too close. 1.25. There we go. I just want to make sure, or too far away. If it's in it, then I might collide with it because it's got its own colliders and stuff like that. So I just don't want to have that issue. So I'm gonna make the gun empty for right now because what I'm gonna do is underneath this, I'll have different models for the gun. So when we pick up different weapons, the gun will look different. Last time I just did a cube. So kind of like how player will have the model underneath, the gun will also have something underneath. And in fact, I'll just do that now so you can see it. So we'll just go ahead. I'm just going to do a cylinder and we'll just say gun model. And I'm going to go ahead and parent that to the gun and I'll zero out its transforms 0, 0, 0. And then we are going to rotate this way 90 degrees. And I'm just going to scale this. So obviously scaling is not generally good, but what I'll do is I'll just have a different model anyway. So this is purely, for visual purposes. There we go. And I'm actually going to take the capsule collider off of it because the balls are going to come out of it. I don't want them bumping up against it. So there we go. So now we have this, looks like a virus or something. Pretty exciting. All right. let's just give this a material too. So we'll just again do another material, and I'll call it gun material. And I'm actually okay with that color. We'll just keep it. Oh, actually, I want gray. So let's just go like this and make it gray. There we go. And that way, it will be, there's our gun. Okay. Just to real quickly kind of get a look of it. Let's go ahead and take the camera. And I'm just going to move it up like this. And I lost it. So we'll say up like this, and then we'll rotate it down like this. So let's say we do 60 degrees, and let's just keep going up till I see it. There we go. Like that. That looks fine. So let's say we do 20. There we go. And that's somewhat centered. I'm also going to change this so that it's 69. A little more control, but that's pretty centered. That looks pretty good. Yeah, I think that is fine, right? Do I need to change anything else? Let me see, it's all zeroed out, right? Yeah, okay. So say that's good. Just gonna go to the game manager, and just so we can adjust the look, I'm gonna add an override, go to post-processing, and see there's a bunch of ones. Last time I did bloom. I think it might be cooler to do some of the other stuff. So let's do film grain, type, intensity, and response. So let's do intensity. I don't know if you can see it, but there's a little bit of film grain. Okay, let's do another one here. Chromatic aberration, color adjustments, color curves, color lookup, depth of field, lens distortion. Let's do color adjustment. And I want to do the color filter, and I'm going to give it kind of I want to do like a more old-timey kind of look thing. And then contrast, do like that. And let's see, and we'll do something like that. It's going to give it a different, more gritty look. You can play around with it, but we'll call that good. All right. Let's see what we have here. All right, so now I have the basic bones of my stuff going on here. So the next thing to do would be to get the game kind of working here. So let's go ahead and create the C# script. Not that, actually. We'll go ahead and make it, but then I'm just going to delete it. I meant to make a folder for it. Okay. And then we'll create folder, scripts. Okay, open that up. Come on. And then we're going to create C# script, and we're going to call this player input. I'm going to do player input because that's basically what it's doing anyway. So we're just going to go ahead and take another player input. And so, doink. Okay. Okay. So let's open that up. And we're just going to put this over here. And we'll go like this. And I'm going to close out of that. So last time I did a controller, and I guess I'll set that up too here, but yeah, so I might try and see if there's a way to just detect if there's a controller. I'm sure there is, because obviously it is detecting controller, but I'll do that at the end. So for now, we'll just do the same thing we did before. I'm just going to do a public bool, and we'll say using controller. Actually, I'm not going to bother with that right now. We'll do that afterwards. Okay, so what we'll do first is we're going to make this just a singleton so that everybody can see it. So we're just going to do a public static player input, public static player input, and we'll just call this player. Good. And then we got to put this on awake. So void awake, like so. And we're going to just go ahead and do player will be equal to this, not thins, wheat thins. All right. So that should be good. And now what we want to do is we want to get our left and right inputs. So before I can really do this, I need to define them in the input of my Unity. So I'm going to go back here. And we're going to go to edit, project settings. We want to go to the input manager, open up these. And we already have horizontal and we have vertical. So I'm going to leave those two alone, but we'll just duplicate them to make the other ones. So I'm just going to right click over this and go duplicate array, right click, duplicate array. And that way we can have horizontal left and horizontal right. It'll make things a little bit easier. Put that one over there to make sure I get these right. Okay. Yeah. Okay. So we're going to take this one and we'll name one horizontal left. So that'll be for our WAS left. And what we want to do is we want that to be the AD whatever here, right? But I don't want it to be the left right. That's going to be my horizontal right. So I'm actually just going to remove these, and then we'll just make the negative button A and the positive button D, and then just go ahead and remove these. And that should be fine. So that should be our horizontal left. Then we're going to take this one and we'll do horizontal right. And we want to do the opposite. So it already has left and right. So we're just going to go ahead and remove both of those. That's good. And now we got to do vertical. So I'm just going to right click and duplicate array, right click, duplicate array. And so we'll call this one vertical left. And we want that again to be the S and W key. So we'll do S, W, and then just remove them here. It would still work either way, but I just like the idea of them being there instead. And then we'll take this one, I'll make this one horizontal right. And let me see, I didn't want those up and down, so I just delete these. Okay, so that should work. So now we have horizontal left and vertical left, and we have horizontal right and vertical right. And that way we can just, use both of those things in order to get it to work the way we want. All right, so let's go back to our code. And we can start basically reading those. All right, so let's take out this, and I don't think I need start. Okay, there we go. And instead of putting everything inside of just the update, I'm gonna have the update just run something because I just think it would look cleaner. So we'll just say, we'll just call it, what would I want to call it? Let's call it read inputs. Right? And then we'll just make a function down here. Void read inputs. It's not going to ask for anything, and it's not going to give anything. Okay, so we need to do our left stick direction and we need our right stick direction. So the idea here is that what we're going to do is not there. Is that using the horizontal left and the horizontal right, we're going to find the direction, the angle that we want, right? So we're going to read the up and down on the left side, and we're going to read the left and right. So basically the W and S and the A and D, or if we're using a controller, which I haven't set up yet, we'll set up afterwards, same idea, right? So if I have this controller here, so this is left, so it'll be this side. All right, so it's going to read up or down, right? So that's obviously up and down, if we can see it. But we also want to read left and right, okay? So by getting those two, if I get up and I get right a little bit, I can see that it's more obvious on the controller that we can see what direction we should be moving or turning depending on what controller. So really what we're going to be getting is a directional component, not a strength component, right? So remember, we're going to have to actually normalize this value. So that way we can just find out which direction is the stick going. In this case, it'll be the WAS keys, but it represents the same factors. So I'm going to read both of those and then put them into a vector, and then I can use that and multiply that times speed for movement, or lerp from whatever current position we're in and lerp to the other position. So I think I can just close out of that. So we'll go back here. So what we're going to do is we're going to make a new vector 3. So it's going to be vector 3, and I'm just going to call it left stick direction, so that we know what it is, and it's going to be equal to a new vector 3. So we're constructing a new vector, and then we have to give it the 3 values. So if you remember, it is X, Y, and Z, right? Because it's a vector 3. So we have to give it those. So the nice thing is Y is not one of our factors. We're just going to put a 0 there. That one doesn't matter because we're not looking up and down. We could put that in there, but we want to make sure that we're looking left. Our up and down we're going to use is going to be the Z, right? So forward and back and side to side. That's where I'm looking for the direction. So we're going to pump those in there. So we're going to put our horizontal left here and our vertical left here. So this is just going to be the input dot get axis And we're just going to say what we named it, which was horizontal left. And then we could just copy that for the other side, Control C. And instead of Z, I'm just going to paste that there, and it's going to be vertical left. Vertical left. All right, so basically that's our X, that's our Y. Now what we want to do is, just as like kind of a precautionary thing, we're going to say if the left stick direction dot square magnitude if that is greater than 1, then we're going to go ahead and tell it to make the left stick direction. We're going to have to tell it to normalize like that. Okay. Basically, it's just making sure that for some reason these values are greater than 1, meaning moving in one direction, and that's a dot. That's supposed to be if it's greater than. There we go. Because think about it, if I have both up and to the right at full value, it's actually going to be over technically a total value of 1. So that's what, if you remember, the normalizing just makes sure that the distance from left, or from the start, the origin, and the not insertion, but the origin and ending point, the starting and ending point, equals a total value of 1. So normalizing is just going to make sure that it does that, because I just want directional stuff. I don't want strength. And I forgot to put the semicolon here. Nobody said anything. All right, so that looks pretty good. I'm just going to literally copy that and just put it on for the other side. So Control V, and instead of left stick, it will be right stick. I'm going to put right there, and we will put right here. And so new vector 3, and instead of horizontal left, it'll be horizontal right and vertical right. Okay, so now we are basically reading both of those elements, and we should get value. So just to make sure that this is all working all hunky-dory, I'm just going to do a debug.log. It's always good to test things. And actually, I don't want to do quotes. We're going to say that we're going to do left stick direction, and that should give me that value. So I can just test where the left stick, and then we'll do one for the other side as well, debug.log, and we'll do, oops, not that, right stick direction. Now this will be too much, so I'm just going to comment out this one, and we'll save it. It's going to go here and go to my console. Actually, can't do that yet because I actually got to put that on the player itself. Wait for errors, no errors. I'm going to drop that onto the player. So it should be on player now, right? Good. Okay. And we're just going to hit play. And I'm just going to use my WAS keys because it's my left input. And you can see it goes to a -1, which is good. Go over here, goes to a +1. That's good. Up should go +1, and down goes -1, right? So this is my W key. Well, now it's updating the wherever the 1 up here. But yeah, so it's doing what it should. That's great. All right, so we know that's working. And I can just test the other one real quick. So I'll just // just to make sure there's no, nothing odd going on. Just constantly test your stuff and make sure that it's functioning. Play it, and now I'm just going to use the arrow keys. So I'll go to the left, and it goes to a value of -1. If I push to the right, it goes to a value of +1. If I push up, this will go to 1. Push down, this will go to -1. Perfect. Okay, so that's all working all hunky-dory. No issues. All right. So now what I want to do is that these are reading the inputs, which is great. That's what this whole thing's supposed to be doing. However, it's not doing anything, right? It's just reading the inputs. I want those to actually do something. So what we're going to do is we're going to make another script that's going to handle the movement, and we're just going to do it that way because we can apply the same basic stuff to the other stuff. So I'm just going to right click, create C# script. Now I was going to call it movement motor, and we'll open that up. And I'm just going to pull that over because that's not really super handy. And I'll take this, take this out. Okay. And take this out. Okay. All right. And what I want to do is we're going to make a couple of public variables that we can access from the other script so that this script will change these vectors for us. So we're going to make two vectors. We're going to do public vector3, and we're going to call it the move direction. And we'll do another public vector3, and that will be the look direction. And what we're going to do is we're going to use both of these values that are going to be changed by this in order to drive the movements. Now, what we also want to do is we want to decide how fast we can turn and how fast we can move and how fast we can turn. So we're going to make another two variables. Actually, they don't even need to be public. We can just do serialized field. So serialize field. I spelled that totally wrong. Serialize field. Is that right? That way? Let me see. Definitely that other way. Okay. Now it looks weird to me. Is that like that? Okay. We'll find out if it's wrong in a second. So we'll do move speed, and we'll just give it a value of 10 to start with, and actually needs to be a float. We have to write that in there. Okay. So serialized field float, and we got to do equals. For some reason I can't seem to write variables anymore, and we'll just paste it, and this will be turn speed. So turn speed will be also 10, and I'm just going to put an F. It doesn't really matter because there's no points on it, but still makes me feel a little bit better. The other thing we're going to need in order to cause the motion to move things, we're going to need the rigid body. So I'm just going to do a private rigid body, and then that will, I'm just going to call RGBD, and we'll just it's not a capital. And then on awake, we're going to assign it. So we'll do void awake like this. And we're just going to go ahead, and I have something that will hold my rigid body, right? This is a variable that holds that value, but there's no current value in this, right? So if you look at here, we made a float, right? So it will hold a floating point, a decimal point number, right? And we call it move speed, but we give it a value right off the bat. These also have no value. So this also has no value. So I'm going to give it a value. I'm going to give it the rigid body. So we're just going to say RGBD is going to be equal to get component. And we want to get the component, the rigid body component, and just like that. And that just means it's going to grab the component from the currently, whatever object that this script is attached to, it's going to grab that one rigid body. Okay. Now what we want to do is I'm going to get rid of the start. We don't need that because I did that other stuff on awake. And again, instead of putting this into update like I did last time, I'm actually just going to call to another function just because I feel like that's cleaner. And what we'll do is we'll just say, move. I don't know if that's void move. That might be a keyword. I don't know. Let's call move, see what happens. All right. So yeah, and we'll call move here. So on every update, it's going to run a function called move, and then whatever's in move, it's going to make it move. And then I'm also going to do a void fixed update, like so. And I'm going to have that one, we'll call that this one turn will be the name of this function because this will turn the player. Okay. Oh, actually, these are backwards. This guy should go there. Not bad. We're turning on this one. Control X, and we're moving on this one. All right. All right, and so we'll have another function just called void turn. And just because I'm not sure if these are reserved words, meaning that it's already being used by these namespaces up here. I'm just going to save this and go back real quick and make sure there's no errors. Because move seems like something that might be, but maybe that's so broad that it wouldn't do it. And it looks like it didn't. So that's good news. All right. So now we're just going to go ahead and do our move. And we're just going to say, let's see, fix it. Or we'll do turn first, actually. Doesn't really matter. I don't know. Okay. So what we're going to say is if the look direction dot square magnitude is greater than 0.01 f, then we're going to have it turn. Okay. So again, what this means is that look at the vector. And if I'm again using controller is the best way to look at this, because if I'm using the controller here and I'm moving my left stick here, right? If I only move it just a little bit, it's not going to start turning. It has to be past 0.01. So meaning more than 10%, more than 1%. The idea here is that if I just made it all the time, then it might constantly be trying to turn, because like it would just, there's like microscopic values. So this just makes sure it don't start turning until at least that threshold is reached. And then we're going to tell it to turn. And we're just going to use a alert for that. So we're just going to say transform dot forward, which is just a shortcut for meaning the forward Z direction. If you remember here when we were looking at this, it's going to give me an error now, but when we look at the player here, notice that when I hit W, right, the forward direction is its Z. That's considered forward because that's depth. So that means we're saying take this direction and I want to set you into a direction. So that's just a shortcut to say take the forward direction and make it this. So we're going to make it a vector3 dot lerp, because I want to blend it into a new motion. So when we do a lerp, it's going to take where you're starting, so we're going to go from where we're starting to where we want to end, and then it's the time, or actually it's not the time, it's the fraction of time that it takes to get there, or it's the length, it's the part of the journey that you're in, like whether, so for instance, it would be like, are we 1/3 of the way? Are we 2/3 of the way? That determines where it will be in that. Okay, so our start position is going to be where we currently are. So transform dot forward, right? So our current angle, and then our end position is going to be the look direction, where we want to look at, right? So if my character's looking forward and on my joystick I'm pushing to the side, my current position is where I'm currently looking. It's always going to be forward in comparison to the player, but my end position is going to be wherever this joystick is pointing. That's my end position. So starting here, I want to get to here, and then here is where we're just going to do a little bit of a hack, where we're going to say time dot delta time times the turn speed. So what that means is that it's going to move it at the increment of if you remember, time is the current time. So when you start playing the game, it starts at 0 and then it just keeps adding on, just like you turned on a stopwatch, right? So it's recording and it's just playing. Time.delta time is actually the time between each frame. So potentially actually that time changes, because if you play a game and it starts to chug, right? Well, the time.delta time, that time becomes larger. But if you have a game and it's like liquidy smooth, that time.delta time is going to be very short because it's running a lot of frames per second. So this is actually good, because what it's going to do is it's going to adjust for what we're seeing. Because if the game's going slow, it will make the increment, larger between frames. But if the game's running really fast, then it's going to make the increment smaller. But as far as you see it visually, it's going to look that way. And then we're just going to take it times the turn speed, which is just a multiplier, so we can decide how fast we can turn. And we put that up here. So we're going to have one for move and one for turning. Okay, so we're going to look at turn every frame. And then the other thing we want to do is this move. Let's save that and just make sure there's no errors real quick here. Voila. Now I'm going to go back here and we need to do the move. So for move, I'm just going to go ahead and do, we're just going to add a force to this. So RGB.add force. And that's just one of those built-in things that are on the rigid bodies. And we want to do is do the move direction times our move speed. Okay. Minus our velocity. RGBD dot velocity. And then the other thing we can do is we can choose what kind of force we want to add. So if you remember what we've done before, we've done the force mode dot impulse. That's really good for like an explosion. What we're going to do though instead is we're going to do velocity change. Velocity change, like that. So it's going to be more like adding onto it. But you can see we actually subtract the velocity here. So that way it's not affecting where we're already moving. So that should, otherwise we would look like we're slipping around. Let's go here. Now, if I were to play this, nothing's going to happen because it doesn't have the movement motor. So let's go ahead and put that on the player. Okay. Now, if we were to play this, still nothing's going to happen. And the reason why nothing's going to happen is that I didn't set up the keyboard yet. You can see the move and look direction. See, these numbers aren't being changed. Right. So we might have the stuff built in here, but without these, now if I move these numbers, oh, they're rigid body. Oh, we didn't attach a rigid body. Whoops. Okay. So on the player here, let's add a component rigid body. Forgot about that guy. And that's fine. I'm just going to collapse some of the stuff here. Now we play. But if I change these numbers here, you will see that will, right? So I'm actually, in a weird way, am able to control my movement by these numbers. Instead of using the controller, because I don't have the hooked up yet, I'm using this. And I can change the rotate here. It's kind of neat, right? Woo! Looks like it's party time. Okay. But instead of me driving it in the inspector here, obviously I want the player input to do that. So all we got to do is on the player input, I just need to make a variable that's going to hold the movement motor. So did I do this last time? I'm trying to see if I actually grabbed it manually. Okay, I just wrote it that way. All right, so we'll hold something that holds it. So we'll do a private movement motor. It has to be because it's the type of this script. And we'll just call it move motor. And I'm just going to go ahead and on the awake, we're just going to attach it here. So we'll just say private, or we don't private, move motor, and it's going to be equal to get component, and it's going to be of the type movement motor, like that. And now whenever we use movement motor here, it's going to be the same as doing this. So what we want to do is just give it those values. We want to give it our inputs here, right? So now I could do another function that calls the other thing, but I think what I'm going to do is just do it inside of here. So we'll just say move motor, because that represents the script dot. And what we want to do is we want to access the move direction and the look direction. Okay, so we'll do look direction first. So look direction. And we're just going to say that is equal to the right stick direction dot square magnitude. Oh, okay. So, so we want to do is, yeah, we'll just say square magnitude. Okay. So, yeah.
I apologize to interrupt, but is this recording as well? Just so I could look back. So I missed a little bit. Okay, cool.
Yeah. That's the doing. Okay. So yeah, we'll just say we're going to take the right stick and we're just going to do the square magnitude of it and stick it in there. That's fine. And we do the same thing with the look direction. So say move motor dot move direction, and we'll set that equal to the left stick direction. That okay. And we don't need this either. Actually, let's get rid of that. Okay, like this, right? So we're just going to literally stick each stick into each one of these values. And now if we go back here, and I got player selected. So you should see these values changing, but obviously also our player will be hopefully moving. So if I push to the left, you can see over here, see the value moves. And if I go here, it makes it a -1. It's using those values times the move speed in order to rotate it or in order to move it. And if I use my other one, that will rotate it. So you can see the values getting changed here. Okay. I'm going to do this also just because you saw it was kind of wibbly wobbly. So we're going to freeze our position on Y because he can't go up and down, but he can go back and forth. And we're going to freeze our rotation on X. So I know it's X because if I hit E, I don't want it to rotate this way. I want it to be able to rotate on Y and Y alone. So it's going to be X because I also don't want it to roll. So X and Z should both be also locked. And now we should be able to move around kind of like we did before. So you can see I can turn and we can, Yay, right? So it makes sense. The only thing that you will notice is that when I'm moving around, see how he's always in that one direction. So what would be nice is if I'm not pushing in a direction, like if I'm not using the right stick, that my character would then subsequently use the left stick to determine its look direction. So for that, we're going to just use an inline if statement or ternary, whatever you want to call it, in here. Okay, so instead of just look motor is this is going to be equal to right stick. What we're going to do is we're going to test the right stick strength. So just like we did before, I want to test whether I'm pushing whether I'm actually pushing on it. So we're going to say right stick direction. First we do our condition. So it's going to be right stick direction. I'm just going to do square magnitude because that just it'll give me the value, and we're just going to say if that is greater than 0.1 f, okay, if that is the case, then what we're going to do is we're going to say it is the right stick direction. So basically, if we are pushing on the right stick, right, then make the value of look direction indeed the right stick. But if not, we're going to say it should be the left stick direction. Right. So the idea here is this first section is basically our condition. And then this is if it's true, and this is if it's false. Right. And it's just so we can do it on one line. It's particularly handy to do these when you're actually trying to put something into something like you're trying to do an assignment. Anyway, so we'll do that. And now when I go to play this, I keep trying to use my controller here, but now when I go to play this, hit play. The player you should see that he's going to point in the direction because I'm not holding. However, if I do use the other one, it will supersede that one's direction. So you can kind of see how that works. But the other one will have control if it's not that case. So you can see, yay. I look like one of those like that Spore game where they had like the pill with a straw on it said, okay. That looks pretty great. All right, so that is mostly good. Although I think my turn speed could be a little bit better. So let's do like 20. It's felt like he's moving kind of slow. Let's see. Although it's harder when you, yeah, that's a little better. All right, so great. The other thing I want to do actually too, just because it's not showing up right yet here, but I'm going to turn off use gravity. That way, what'll end up happening is that the player actually like rubs up against this, and then it starts making them spin and stuff. So I'm going to take gravity off, and that way we won't deal with that issue. Okay, so we're going to say that is the player to start with. Would be nice is if we had some shooting because I want to put the enemies in there, but they're going to keep bumping up against me. So let's get the gun going, I guess, next. And then we'll go from there. So this down and out of the way. Okay, where's the gun controller? All right. So over here, we're just going to go ahead and right click, create C# script, and we'll call it gun controller. And I'm going to slap that right onto my gun here and gun controller because the script cannot be found. Oh, wasn't done making it apparently. It's a little too fast. Okay, now I'm going to put that onto the gun here. So the gun has the gun controller script. Let's go ahead and open that up. And let's get rid of the business. All right. And this one's going to have quite a bit of stuff in it. So trying to think of the best way to go about doing this. I did want to do the gun a little bit different. Okay, we'll just do this to start with. So I'm going to start off real simple. So what we're going to do is we're going to do a public game object, and these capital O object, and we'll just call this bullet. That'll be the default. And then I don't need the pool yet. We'll also do, yeah, we'll start with this, and then we'll kind of update it as it goes. Okay. Actually, I also need. What is that? I don't see it in here. Okay. We're also going to make another variable called public bool, and that can be let's call it trigger. See, trigger's not a good name. Trigger pulled. Basically, I just want to like set that to true if the player's pulling the trigger. So we're going to again use our player input to give this a value, and we'll set that to initial value of false, which I think it's false by default anyway, but we're just going to explicitly say so. All right, so let's see, what do we need to do first? So I'm gonna have to attach it, and then basically we'll just set up an if trigger pulled, right? That's true. I'm gonna have you instantiate. It's gotta be a capital I. Instantiate. I think that's right. And then I'm just gonna say the bullet. So let's do it like that. That should work. So in order for this, I'm just gonna go here and make sure there's no errors. Shouldn't be, because I didn't really do too much. So normally when we do instantiate, we usually give it a position as well as actually we do need to do that as well as a rotation. So actually we do need to put that here. So because right now, if we instantiate the bullet, it's going to instantiate the bullet wherever it is. I want to instantiate it where the gun currently is. So we're going to go ahead and say transform dot position, and then we're just going to do quaternion identity, which means just the default, which just means it's going to be wherever it is. Okay, we'll do that and go back. So that should be all zeros. And then what I'm going to do is make a prefab bullet. So we're going to create folder. We'll call it prefabs. And we'll go up here and we're going to do a 3D object. And I'm just going to go ahead and do a sphere, and I'm going to call it a bullet. I'm going to zero it all out. 0, 0, 0. Great. And it's got a sphere collider. That's all goody goody. And I'm going to put that into my prefabs. Great. Okay. So now what I want to do is on my gun, I'm just going to go ahead and drag my bullet on there. And we are going to save this real quick because when I do pull the trigger, which currently I don't really have that set up, he pooped. Yeah, don't worry about that. Nothing happens. Oh, because I never changed this value. So you can see if I hit trigger pull, crap. Okay, God, that was stupid. Because I hit trigger pull, it's just going to keep making them forever. I don't know if you saw that, but it really quickly made a whole bunch of them, which I did not want. So we need to make it fire when we tell it to fire. So this is one of those things that was different depending on whether we were using a controller or not. So I'm just going to set up for not the controller right now, and then later on we can put that in there if we want. So we got this read inputs. Yeah. All right. So just after this stuff here, we're going to go ahead and do if the right stick direction, because that's our pointing direction. If we're just going to test its square magnitude again. So basically its strength. If that is again greater than 0.1 F, then we're just going to tell it that the gun dot what is it? Oh, I didn't hook myself up to this actually. So hang on a second. We need to make a variable that's going to hold it first. So we're going to go up here. I'm going to do private gun controller, and we'll just call it gun. And then we're going to hook it up here on the awake. We'll say gun is going to be equal to get component, and it's going to be the gun controller, and like that. And now I have access to the gun. So down here, we're going to say, okay, take the gun dot, I think it's trigger pulled. Is going to be equal to true. Okay. Do need a way of turning it back off. So actually, this is going to make it crash too. Now that I think about it. Oh, we'll just do an else real quick. We'll say gun trigger gun dot trigger pulled will be equal to false. So basically, it's only going to be on when we're pushing. So if we're not pushing at a certain thing, then it's going to go back to off. So that way we have a way of turning it off. This isn't very clean, but you'll get the idea. It's going to make way too many. But we should, be instantiating bullets. So go ahead, hit play, and okay. Oops, didn't like something I did. Object reference not set to an instance of an object. Yeah, hang on. It says on line 37. Gun triggered pull. Oh, I know why. So the problem is that I'm reading this from the player, and so I did get component. There's no gun attached to this player. It has to be get component and children. So right here, it's up in the top here where it says get component. It's got to be get component and children, like that. That should work. Now we hit play. Because it's in its child that has the gun. So if I go left and right, you can see like that's great. But if I push up, you can see I can do a whole, looks like I'm pooping. If I push down, woo, and this way and that way, it's kind of cool. All right. So yeah, that works, right? So now when we push in direction, it will make these things. It's kind of be a cool little like snake game or something, right? If you did this right, that's kind of cool actually. All right. So that's now functioning, so that's great. And we're just doing it through, I'm just trying to get it to somewhat work, at least to begin with. So now when we push a direction, it will turn the fire on and we will be good to go. Okay. So it triggered pulled, it's going to instantiate, yada, yada, yada. That's great. Let's do, uh, let's do another thing first. So I'm going to do this a little bit differently than I did last time. So I have the gun. So last time what I did is I had this bullet and I had it that we just shoot the bullet and then I just changed things about the bullet. But I was thinking it might be better to have different bullets because visually this just looks like this. So I think I want to do a new script for bullets specifically. And then I'm going to have the bullet self-propel itself. So I'm going to go to scripts. We're going to create a new one, C# script, and we'll just call this bullet controller. Open it up. All right. And what we're going to do is take this out. And we are going to need a couple of things. So this is going to need a rigid body in order for us to apply it. So we'll just do private rigid body. And we'll just call it RGBD, just like everything else. And then actually, I want to do it that way. Private RGBD. Yeah, then we're gonna do void. Oops, void awake. This might not work because of one thing, but we'll see if it works. So then we'll just do is RGBD will be equal to get component. I'm gonna get its RGB or its rigid body component. Stick that in there. That'll be fine. And then what I want to do is have a function. We're gonna make a new function called void shoot. Okay. And what I have it do is that I'm going to have amount of force. So we'll do a public, or actually we'll do a serialized field, and we'll do make a float, and we'll say bullet speed, and we'll set that equal to 100 to start with. And then what I'm going to do is apply a force to that. So where are you at force? There it is. Okay. So what we're going to do is when we shoot, we're just going to go ahead and do RGBD dot add force. And the force we're going to add is going to be, so we need the direction and we also need the strength. So transform dot forward, want to be in the forward direction, times the bullet speed. And I'm also going to go ahead, and I didn't do it last time, but let's do force mode dot impulse. So that way it shoots out. I think, yeah, I'll try that. And if you look, nothing, let me just make sure there's no errors here. It's not actually going to do anything. So I'm going to open up the bullet. So I'm going to go to my prefabs here. I'm going to open this bullet up, and then I'm going to go to my scripts, and I'm going to drag my bullet onto this. And so this is all fine. But if I go to play this, you're going to see it's not going to do anything because that function never gets called. So, I can push in a direction and it's going to push them out, but see how they're not moving. So I got to do is go back here, and I have to call shoot, but it makes the most sense to call shoot on awake void or on enable. And so basically when it's turned on, we're going to say shoot me. Okay. So now yeah, see, that was my concern. We're going to do this real quick first. This will work, but it's not going to work right now. So the problem that's happening, just so you can see what the error is, it's saying it's trying to catch a rigid body, but the script is trying to access it, but it's not there. And you'd be like, oh, but it was there. Because it has, oh no, it doesn't have a rigid body. Never mind. It's not there. Go back. Thought I put it on there already. Oh, maybe this will work then. Add component, rigid body. There we go. And I'm also going to turn off use gravity, and we'll freeze this position on Y, and I'll leave all the rotate. We'll also freeze this here. Freeze position, and then I don't care if it spins. All right, let's see if this works now. Oh, there it goes. Oh yeah, that's great. Whee! Okay, so obviously there's some issues there because it's just always shooting in a forward direction, which is or always in that direction. So I just need to change some of the aspects here. All right, so all right. Okay, so we're going to instantiate the bullet. Bullet's going to shoot. It's going to shoot from the position that this is in, but then its rotation is currently this. So I need to give it my gun controller's rotation. So let's see if we can do this. I'm not sure if this is going to work or not. Let's try transform dot rotation. I don't think that works because I think it's like a weird. So, oh, it did work. Okay. All right. So now it's inheriting the rotation. Now it's like crazy. It's inheriting the rotation of my object. So basically, when I instantiate the bullet, it's going to go all that stuff, but it just automatically shoots itself. The reason I want to do this is what I'm going to do is I can make multiple bullets, and then like I'll have one for an explosion, one for whatever, and that way the bullets themselves are doing it. Otherwise, once we shoot the bullet, I have no control over it. So yeah. Anyway, that's what we're going to do. So that looks acceptable. So I guess now we're shooting. But I do need to fix the shooting a little bit because it's just doing way too many, right? So I was doing the weird spread thing. So what I need to do is I need to hook up some variables to keep, what my shoot rate is, things like that. So, because when you do look at it like physically too, bullets are, the bullet itself does all the propulsion, right? Like with a gun, like a real life gun, all the gun does is hit the back end of it. So it makes sense for this to actually do it itself. However, and they have different things about it, the amount that it shoots and how fast it shoots and things like that, that is on this end. So we're going to go ahead and we're going to add some variables here to adjust those aspects. So we'll just go after this one. I'm going to do public, and we're going to do we don't need shoot speed. Oh no, we do need shoot speed. So we'll do public float shoot speed. So how fast it is to shoot. And then and then I'm going to need some other variables. So I have this one's public, but really it could be private, but I'm going to do private. And then we're going to also keep track of our last fire. So last fire. and we'll set that equal to 0 to start with. So basically, every time we shoot, we're going to keep track of the last time we shot, so that way we can just add to it the shoot speed, which I'm going to give that a value of 0.1 f to start with. Okay. All right. So what we're going to do is we need to basically add some options to this. So first off, it should be if you pulled the trigger, and so 2 ampersands, and the current time, so time.time is greater than the last fire plus our shoot speed, right? And then every time we shoot, after we shoot, we're going to go ahead and do last fire will be equal to the current time. So basically, when this runs, right, the first time it's going to run, it's going to say, okay, you pulled the trigger, that's fine. Is the current time, is it later than the last time we fired plus the speed, right? So if last time we shot was, let's say 3 seconds, right? And then the shoot speed, let's say is, we have it as 0.1, but let's say it's 1, to say, okay, is the current time 4 seconds? Because the last fire was 3 seconds, so you can only shoot every second. And if it's true, then it'll be able to shoot. And then what's going to do is going to take that time that we just shot, which will be at 4 seconds, and make that last fire. Then next time we come up here, if we pull the trigger, right, it's going to say, okay, is the current time, is that at least, like if it's at 5 seconds, right? If last fire was 4 seconds, and again, we're adding this, then that would make it 5 seconds, and we're going to wait till the current time is 5 seconds. It won't let us shoot again. So that's kind of it in a nutshell. Yeah. So we'll save that, and we're going to go back here. Doop doop doop. And now it's just 0.1, but now we should be able to. So it's still shooting pretty fast. But you can see it's not doing this immediate, like it's not doing like just a constant stream. So I'm gonna go here and let's do the shoot speed 1, just so we can see that's working. And it's gonna only shoot every 1 second now. Okay, so that's how often we can shoot, is based off of that factor. So yeah, great. Let's make that 0.25 quarter second, make a little more, you know, a little more difficult. Okay. The other thing I want to do, just because this needs to be built into this, is after we shoot, I need to kill the bullet. So we're going to do, after this, it's going to be, we're going to run a coroutine, if you remember. So we'll make a new one, and it'll be enumerator, and we'll just call it kill bullet. And the kill bullet, we're going to say, I want the bullet itself to determine how long it lives. Oh, you know what? We're not going to do it in here. We'll do it in the bullet itself. I'm going to go to the bullet, and what we're going to do is on enable, we're going to run that coroutine. So we'll do start coroutine, and we're going to call it kill bullet. And I'm going to go up here. We have bullet speed, so we'll do another serialized field. Dang it, this one, serialized field, and we'll just do a float, and we'll say bullet lifespan, and we'll make that equal to 1 second, we'll say. Okay. So, and so we're gonna, when we call this coroutine, actually, we don't even need to do that because it's right up here. Everybody has access to it. I was gonna send it here, but we'll have it anyway. So we're gonna run that coroutine. So it's gonna be enumerator, and it's gonna be called kill bullet. And like this. And so what we have to do first is tell it how long to wait before we do it. So it's going to be yield return new wait for seconds, and it's going to be this variable we set up here, this bullet lifespan. So I'm going to copy that, and that way what we can do is that each bullet we can change. Thought I copied that. Let's try that again. Control C. So it's going to wait that long, and then what we're going to do is we're just going to say destroy the story, destroy, and it's going to be the game object because this is attached to the bullet itself, like that. All right, so that should work. Oh, didn't like something. Something was expected on line 20. Oh, not there. Oh, forgot it here. There we go. Let's go back. And now if we shoot, we should see that they die. Yep. So they get made and then you can see they die. Right. So it's the circle of life. All right. So now we've got bullets more or less working. I'm just going to go through and that bullet is gigantor. So I'm just going to take the scale of it a little bit. I'm going to lock it and let's do 0.1. Let's hit play. Let's see. Don't see it. Why am I not seeing it? Can't be 0.5. Maybe that's why you can't see it. That's weird. All right, well, we'll go with 0.5. All right, so good. All right, so we have that working. So the next thing is we need an enemy. So like I said, let's save this. Just making sure that we have all the bits we need. So I'm just gonna go ahead and create 3D. Let's create an empty so that we can switch this out. So we'll do enemy and we'll zero this out, zero this out, zero this out. Great. And then inside of that, we're going to make a 3D object. And let's make this guy, let's just do a cube. And we'll just call this enemy model. And we're just going to parent it to the empty enemy here. And I'm just going to zero out all of its transforms. Okay. And good. So now we have this enemy. He's looking pretty cool. He's going to need a script. So the enemy itself is going to need, actually, let's give it a material too while we're at it. So create material, call it enemy material. And we're just going to go ahead and make that thing red, just to make it easy. And we're going to put that on the enemy model. Good. And I'm going to move this out of the way so we can see if it's working or not. 0.5 on up. So that's got that. Let's add some components. It's going to need a rigid body. It's also going to need a collider. So it didn't occur to me actually the player is going to need one too. I didn't put that one on there. The model's got it, but in fact, actually, I'm going to turn that off on the model because it doesn't need it, just like we turned it off here. So on the gun, the player model, turn off the capsule collider because I don't want things to collide with it. This guy is going to need a collider, so I'm just going to add one on here. So say capsule collider. And I think, yep, they made the, so by default, it'll try and make it the size of its child, which is handy. So now that guy's got it, and the enemy's also going to need one. So where's the enemy? There it is. So the model itself, did I turn it off already? Yeah, turn it off on the model. But this one's going to need one, so we're going to go ahead and it's going to be the box collider. And yeah, that's good. Okay. So we've got something to move it with, and we've got something for it to get hit by, and it's got its materials. So now what I'm going to do is on the enemy, I'm going to go ahead and put that movement script because we're going to need that. We're going to lower these a bit. So let's go 5 and 5 to start with. Might need to be faster than that. I'm not really all that sure, but that's at least a start. But it's going to need, you know, a script for itself, and that's just going to be the enemy controller script. So let's just do right click, create C# script. I'll just call this enemy controller. All right. All right, and I'm just going to take that and we'll slap that on the enemy. So that way the enemy's got that enemy controller script, and we will open it up. We will make some stuff. So we need to hook up to the movement motor, just like the other one, because that's what's actually going to drive its motion. So I'm just going to go ahead and do, go into this, we'll just do a private movement motor, and we'll just call it motor. Okay. And then we're going to, on awake, we will hook it up. So we'll do void awake. Okay. And we're just going to, let's put space there. It bothers me. And then we're just going to say that motor is going to be equal to get component, and it's going to be the movement motor type. Like so. Okay, good. So we've got that going on there. That's all fine. But now we need to drive its functions. Okay, so what we're going to do is just do what did I call the other one? I read inputs. Let's just call it movement driver. I don't know. Okay, so I'm going to call it movement driver, and then I'm just going to do void movement driver. Doesn't require anything, and we're just going to put this. So it should be pretty easy. So we're going to make the move motor equal to, and what we're going to do is we're going to look at the position in order to drive the both the actually it's movement motor, sorry, dot move direction. In order to drive the direction, what I need to do is this is going to give me an error in a second, but what I'm going to do in order to figure this out, so I want to be able to tell this a just like, so the way that this moves, right, is we using inputs, right, we give it a vector that goes, you know, +1 to -1 in X, and then positive or -1 to +1 on Z, right? Actually, this is Z and this is X, but you get the idea, right? So, and all that does is it then takes this and then it says, okay, make it lurk to that direction and also move in that direction. It uses basically kind of the same thing. What I need to do is do the same thing here, right? But we have no input. So what we're going to do is we're merely going to look at this guy's position, and I'm going to subtract his position from this guy's position. And what that's going to do is it's going to leave me with a number that's going to be offset by a certain amount, and that's going to give me my vector so I know which direction to go, right? So for instance, let's make this simpler. If this guy's position is 0, 0, right, because he's right on origin, and this guy position is on, let's go in a positive direction because that might be easier. He's in +1, +1. That means that the direction that he needs to go in is going to be in a, if I subtract that from here, from his position, so +1 and +1, it means it's going to be -1 and -1, right? Because negative this direction, because that's going this way, and negative this direction, which means it's going to want to move it that way. That's how we're finding it out. And if I go, you know, down here, it's going to say, okay, so this is 1, 2, 3, and 1, 2, 3, just again to keep it simple. If I subtract that position from this, right? So if I take 0, 0, 0, because that's where this guy is, what that means is that if I subtract the minus, it's actually going to make it positive, right? So it's got to move +3 by +3, which means it's going to make it want to move in that direction. It's going to make its vector that. That's the idea. So that's how we're going to find out what direction this guy needs to go in. So inside of here, what I'm going to do is I'm saying, oh, take the move direction, and I want you to take the player. Actually, it's player input, isn't it? Or no, we called it player. That was the thing. Take the player, take its transform dot position, and then subtract transform dot position. So remember, when you just say transform position, it's the object that the script is attached to. So that means the enemy's position. That's what this represents. Take the player's position, subtract the enemy's position. And then what I want to do after that, I'm going to put these in parentheses because I need to do a function. After that, I need to normalize it. So we're going to say normalize like that. Okay. I need to normalize it because, like the example I was showing here, right? I can't give it a value of -3. I need it to be 1. So remember, the whole idea is that we're trying to get a directional component. So it's 1 unit off like this. So that's what normalize means. Like it might be that the vector we give it is this +1, +1, but I need to be normalized. So if you actually look at this, would this be the tangent of this, right? That's longer than like this distance. See the distance from 1 unit? This is 1 unit. If I went from here to here, that's longer than this. So when we normalize, if I say, oh, I give it this vector, so up 1 and over 1, the normalized version is going to be actually a little bit lower. It's going to be like here, because that's equivalent to the length of this. So the normalized makes it so it's 1 unit offset. So even though we give it that 1 and 1, that's what it's going to do. Okay. The name player is not okay. So I think we got to do player input. Let's see if that works. Okay. Clear. Okay. The name move motor does not exist in the current context. So that's 22. Okay. Oh, whoops. Sorry. It's just motor. I wrote move motor because that's what it's just motor. Sorry. We called it motor here. I think in the other one, I called it move motor, right? Yeah, I called it move motor. So a little confusing. Anyway, so motor. Let's save that. Let's go back here. And then there still is, okay. Vector is not contained definition for normalize. Oh, normalized. Whoops. I want the normalized value. Okay, let's go back here. Good. And all we're going to do is we want it to both move and look in the direction. So we're just literally going to take this and also make it the move motor, but this time it's going to be the look direction. Save that, go back here. All right, and let's hit play. I think it's all hooked up. I can't remember if I forgot something or not, but yeah, there he goes. Oh boy, he is going nuts. All right, not sure what's it. Oh, because I grabbed so it's working right, but because it's offset from the enemy, because I moved the poly, not the dude, the model. That's why it's like looking weird, because when it's turning, it's spinning from this pivot. So I need to take this guy and zero him out. Forgot about that. Okay, and enemy good. Okay. I was like, I don't understand what's going on there. But that actually does make sense. All right, so now you can see, yay, he's coming after me, right? He's struggling with the rotations a little bit, but he's got the right idea, right? He's got the spirit. So we're just going to, on the rigid body, turn off gravity. That's partly what's causing the problem. We're going to freeze the Y position, and we're going to freeze the X and Z rotations. And then we'll play again. And hopefully that will solve that issue. There you go. So now he's looking, right? And that's great. Unfortunately, though, I can't kill him, right? So it's not really much of a game. And get away. No means no. Okay. So yeah, he's coming at me. He's trying to kill me. That's great. Now what I want to do is just have my bullets actually kill this guy. So so what I'm trying to do is I'm trying to think, do I want to make the enemy have the collision detection, or do I want to make the bullet do the collision detection? Because I want to have happen is that when the bullet hits it, that it imposes on it a certain value. And I think, so whether it's easier to have this say, oh, if a bullet hits me, I want you to, you know, take away my life based on a value on the thing that hit me, or if it'd be easier for the bullet to go, oh, you hit this, take away a value of life. And I think what I'm gonna do is I'm gonna do it on the bullet. The reason being is that way on the collision, I can have it get destroyed as well. Because one of the problems that we had when we did this last time is that when the bullet hits the enemy, it got destroyed like it should, but it only did it if it hit somebody. Otherwise, if it hit a wall or something, it just stayed alive because we didn't have a detection, because we didn't put any scripts on the bullet. So I'm going to put on the bullet and have the bullet do the detection. So we have a couple decisions here that we can make. So whether we want to do, when we do the bullet, whether I want this to be a trigger or a collision. And I'm trying to think of what would be best. I think the collision would be more fun because that way when you hit it, you actually do see it like react. Because remember, we have to do that on trigger collision or on trigger enter. So I think I'm going to do it on collision. And then later on, if we want to change it on trigger enter, we can. So I'm going to go back to my bullets controller here. And we're just going to add, I like to keep my custom ones on the bottom, and anything that's like part of the mono behavior, like your on enable, start, update, things like that. I'm just going to take these guys out because they're not doing anything. We might need them later, but I'm going to take, and I'm going to turn shoot to on collision enter. On collision enter. And remember, we have to test the collision, and I always call it COL. Some people call it other things. Get out of there. Okay. And we're going to say is if the thing we hit, if it's so COL dot compare tag, and we're going to compare if it is an enemy, then what we're going to do is we're just going to destroy it for now, just so that it works. We're going to say destroy. Actually, let's do this, because I'm going to have it destroy both itself and the enemy. Destroy, and we'll say COL dot game object, right? So the game object of the thing that we collided with, and also I want it to destroy itself. Destroy, and we'll just say game object, which will just represent itself in this case. Okay, boom. We'll save that. Go back here. Hope for no errors, no whammies. Collision does not contain definition for compare tag. Oh, so I guess I got to do collision dot game object. Game object dot compare tag. And we'll hit play. Oh, and tag enemy is not defined. Enemy is not defined. That is true, actually. Let's go ahead and take this bullet and delete that. And let's grab our enemy, and we need to add a tag to it. So I'm going to go up here, add a tag, hit plus, we'll call it enemy, and go back and do it again because it doesn't actually stick. And let's hit clear. Let's hit play. And let's see if it gives the error again. Okay, it doesn't this time. And let's shoot. Come on, man. There it goes. Great. Okay. And actually, I'm going to go over here, and I'm going to take the destroy game object, and I'm actually going to take that out of there and just make that a, put it up here. This way, that way, no matter what it hit, if it hits something, then it's going to destroy. So I just got to make sure that the gun itself doesn't destroy it. Because we turned off the trigger or the box collider. So I think it's still going to work, but I just got to double check. So yeah, it's fine. Okay. All right. So that looks good. So now we've got that basically going, which works fine. So now we got the basic mechanics. The last thing I really need to do is just spawn my enemies. So that way, you know, the game's a little bit more fun. So we're going to go ahead and do that next. So let's go ahead and just do an enemy spawner, create C# script, enemy spawner, and let's open that up. And let's get rid of this gobbledygook and like that. All right. So first thing we're gonna need is the enemy to spawn, right? So we'll do public game object, and we'll call it enemy. It's a good start. We might eventually do different enemies. Then I'm going to need some variables in order to just keep track of how often it spawns, so that we can determine that. So we'll just do a public float spawn interval, and we'll set that initial value of, let's say, 1. And the other thing I want to do is I'm gonna also need the where to spawn, because we're going to make it random. So let's say public. Actually, sorry, this should be a vector 3. Vector 3, and that will be the spawn area. Okay, and I think that's all I need to start with. Yeah. Okay. So it's just going to be like the other one. So what I'm going to do is instead of doing it right inside of update like we did last time, I'm just going to call I'm just going to call the spawner. So what should I call this? Spawn enemies. That's what we'll call it. It's fine. Boink, and then we'll just make a function called spawn enemies. So spawn enemies, and I got to do more than that. Sorry. Void spawn enemies. Boink and yoink. Okay. And then what we're going to do is just the same thing we basically did with this bullet controller, where we're just going to keep track of the, not the bullet controller, sorry, gun controller. where we're going to keep track of the last time that we did it. But instead of we don't have to have this and in there because we're just literally doing it based off of just the time in general. So it's just this bit here. So we're just going to go ahead and we're just going to say if the time dot time is greater than the oh, I also need another variable here, so we'll do that after this. We'll say a private float, and I call it last spawn time. Yeah, last spawn time. I'll set that equal to 0. So if the time is greater than the last spawn time plus the spawn interval, then you can go ahead and spawn, right? So what we're going to do is we're just going to go ahead and I think we just do it this way. Now, you know what? I need location first. So we want to instantiate the game, the enemy, right? So enemy, but with the enemy, so we need the object, the location, and the rotation, right? The position and the rotation. So this will be position. And then the last one's just rotation. And I just always do that quaternion identity, quaternion dot identity, because that way it's just going to go by default. And this would be position, but I need to figure this out. So if you remember, what we did is we're going to use that that public spawn area in order to determine where it's going to spawn. So we're going to make a new vector3, and it's going to, we're going to call it LOC, and it's going to be a new vector3. And then what we're going to do is we're going to use this spawn area, right? So we're going to make it random though. So it's going to be random dot range. And then we're going to give it the negative value of the spawn area and the positive value of the spawn area. So we'll do spawn area dot x and then spawn area dot x. Okay. But I'm going to do this one minus. So it's going to give me a random range inside of this spawn area. So whatever I put in for x when we have our XYZ, it's going to go from, let's say I put 10, it's going to go from -10 to a +10. And it's going to find a random number within that range. We need to do the same thing for the other. So that's my x, right? And then y is just going to be, well, it's going to be, we'll just do 0.5. Basically, it's always going to be just flat, so it doesn't really matter. But I'm trying to think of a better way of doing it, not like that, this. And then we just want to basically copy this, but do it for y. So grab this, or I'm sorry, z, Control C, Control V, and we're just going to make it z and z. And then we're going to use that, the LOC, as the spawn position. And I think that's all I need to get this spawning to start with. Okay, so let's save that. Line 23, right here. So we're going to make an empty object just to, so I have player enemy. I'm going to collapse this guy as well. So we're just going to make a spawner. So create, and we'll just call it enemy spawner. And I'm just going to zero out its values. Doesn't matter, but you know. And then we're going to throw that script I just made, the enemy spawner script, onto it. And then I need to take this enemy, and it's got to be a prefab so I can instantiate from it. So I'm going to grab the enemy, drag it into here, go back to my enemy spawner, and I'm going to put it up in here. And then what I need to do is I need to determine what the spawn area is. So we want to go, I'm going to do this. So I'm looking at this right now. I'm just going to drag it. Okay, so right there is roughly where I want it to be. So that, if you look, it's 50, right? So that means, and on this end, it would be -50. So that basically means that I want to put in 50 for my x, and then my z is going to be the same because, you know, up here is going to be 50 and 50. So we'll put 50 and 50. So basically it's going to spawn within that range now. And I think that's it. So we should play, and let's see if they spawn the units. This is going to spawn every 1 second, basically. Oh boy. Okay. A little bit faster than I was hoping for. Hang on. Spawn interval. Why you spawn so many? Void spawn enemies if time is greater than last time last spawn time, which is 0 plus, oh, I never add to the last spawn time. So we gotta make last spawn time equal to the time dot time, right? I forgot to reset that. We have to set that every time that we spawn, that it does that. Wondering why there's a million of them. And let's save that. And I'm gonna hit play. And hopefully every 1 second, instead of just ridiculousness, we'll get a new enemy. So yay. Okay, so for all intents and purposes, we have the most basic prototype completed, because bullets are like too fast. Okay, let's take this bullet here. And what are these bullets? Let's do 50. Just can't even see the stupid things. I think if I made more of them too. Oops. Okay. Yeah, I think that's the problem too. Let's take the actually no, it'd be on the gun. Let's do the shoot speed. Let's do 0.15. Just 0.1 seemed a little too fast to me, but maybe it's not. It's just harder with the thing here. Okay, so that works. All right, so I'm going to save this. And what I'm going to do is I'm going to stop the video here because this is kind of a good stopping point. So at this point, we've now done the prototype stage. So I have a prototype. Now I need to make it, I need to polish it and stuff. I need to make things function a little bit better, and then we'll kind of move on. So this will probably be a multi-day tutorial just because I don't think we'll be able to get everything done today. But at least we have a start, and then we'll kind of, go from there.